Good day, sir. I am RGC Barcelona of EK32. Today I am going to discuss patch or microstrip antenna. In this topic, I'm going to discuss the introduction, the body, and the summary of my written research. And in this report, I input 5 questions on this topic. On introduction, one of the most helpful input of these wireless devices is the patch antenna. According to the tech target contributor, a patch antenna is a wafer-like direction antenna suitable for covering single-floor small spaces, small offices, small stores, and other indoor locations where access points cannot be placed centrally. Patch antenna produce hemispherical coverage spreading away from the mount point at the width of 30 to 180 degrees. Moreover, in its most basic form of a microstrip patch antenna consists of a radiating patch of one side of a dielectric substrate which has a ground plane on the other side. The patch is generally made of conducting material such as a copper or gold and can take any possible shape. All in all, this study will cover up the definition, importance, advantages and disadvantages, basic properties, and main application of patch or microstrip antenna. One of the most common form of real antenna is the microstrip antenna. These are extremely important in today's wireless networking networks. In this section, we will discuss about microstrip antenna, their polarization and radiation pattern uses, and upcoming trend. One of the most important elements of any wireless communication device is the antenna. The term antenna comes from the Latin word antennae, since Heinrich Hertz's first example of wireless technologies and Guillermo Marconi's first use in practical radio communication. The antenna has been a key building block in the construction of every wireless communication system. Microstrip patch antenna consists of radiating patch on one side of dielectric substrate FR4 that has a ground plane C or copper on the other side. The patch is usually made of conducting material including such copper or gold and may be any shape such as rectangular, oval, triangular, elliptical or any other normal shape. Typically, the radiating patch and feed lines are photo-etched on the dielectric substrate. Microstrip patch antenna radiate primarily because of the bridging fields between the patch edge and the ground plane. Next is the polarization and radiation of microstrip antenna. The polarization of an antenna is determined by the wave radiating in a given direction. That is identical to the direction of the electric field. The instantaneous electric field vector traces a figure in time. This figure is usually an ellipse that has special cases. In the path of the electric field vector follows a line, the antenna is said to be linearly polarized. If the electric field vector rotates in a circle, it is called circular polarization. So, T is equal to large diameter of the ellipse over the small diameter of the ellipse. Polarization is said to be linear if T approaches to infinity or T is equal to 0, and circular if T is equal to 1. There are two subtypes linear polarization, the vertical polarization and horizontal polarization. When E, field vector of the EM wave, is perpendicular to the Earth, the EM wave is said to be vertically polarized. When E, field vector of the EM wave, is parallel to the Earth, the EM wave is said to be horizontally polarized. Next is the various types of microstrip antenna. The radiation pattern is graphically depiction of the relative field strength transmitted from the received by the antenna. Antenna radiation patterns are taken at one frequency, one polarization, and one plane cut. patterns are usually presented in polar or rectilinear form with a decibel strength scale. These are normalized to the maximum gap value of 0 decibel and directivity is given for the antenna. This means that its side lobe level from the radiation pattern were down to negative 13 decibel and directivity of antenna was 4 decibel, side lobe gain would be negative 9 decibel. So, pinapakita lang po dito yung comparison of various types of microstrip antenna. So, meron po tayong 7 characteristic: the profile, fabrication, polarization, dual frequency operation, shape flexibility, spore use radiation, tsaka bandwidth. So, sa microstrip patch antenna po, yung profile po is thin. Sa microstrip slot, thin din po. Sa printed dipole antenna is thin. Sa fabrication po, sa microstrip patch po is very easy. At sa microstrip po at printed dipole is parehas po easy. Sa polarization naman po, sa microstrip patch is both linear. Pati na din po sa microstrip slot na both linear po, pero linear po siya sa printed dipole antenna. Sa dual frequency operation naman po, it is possible. Tapos, sa microstrip slot po, possible po siya also sa printed dipole po. So, shape flexibility po, sa microstrip patch antenna, any shape po siya. Sa may microstrip po is mostly rectangular or circular. Sa may printed dipole antenna naman po is rectangular and triangular. Spurious radiation po sa microstrip antenna is nag-e-exist, pati na din po sa microstrip slot at sa printed dipole nag-e-exist po. Sa bandwidth naman po, sa microstrip patch antenna is 2.50%, sa microstrip slot naman po is 5 to 30%, at sa printed dipole po is 30% po. Next one is the advantage and disadvantages of patch antenna. The advantages of microstrip patch antenna are: first, planar, which can be also be made conformal to a shape survey. Second, low profile. Third, low radar cross section. Fourth, it is raw. Fifth, can be produced by printed circuit technology. Sixth, can be integrated with circuit elements. Seventh, can be designed for dual polarization operation. Eighth, can be designed for dual or multi-frequency operations. And these are the advantages makes microstrip patch antenna much more suitable for aircrafts, spacecrafts, and missiles that conventional antennas, as they do not interfere with the aerodynamic of these moving vehicles. These are the next one is the disadvantages associated with microstrip patch antenna. The first one is, in its basic form from microstrip antenna has a narrow impedance bandwidth, typically less than 5%. However, various bandwidth widening techniques have been developed up to 50% bandwidth have been achieved. It is generally true that wider bandwidth is achieved with a sacrifice of increased antenna physical volume. Due to the small separation between the radiating patch and its ground plane, the microstrip patch antenna can handle relatively low RF power. The average power considered safe is a few tens of watts. Next is the main application and basic properties of patch antenna. Communication-based application, microstrip patch antenna fills several applications in wireless communication. For example, satellite communication requires circularly polarized radiation patterns, which can be realized using either square or circular patch microstrip antenna. In global positioning satellites or GPS systems, circularly polarized microstrip antenna are used. They are very compact in size and quite expensive due to their positioning. Microstrip antenna are also used in the fields of RFID, or the radio frequency identification, mobile communication, and healthcare. A microstrip or patch antenna is a low profile that has several advantages over other antennas. It has lightweight, inexpensive, and electronics like LNAS, and SSPAs can be integrated with these antennas quite easily. While the antenna can be a 3D structure wrapped around a cylinder, for example, it is usually flat, and that is why patch antenna are sometimes referred to as planar antennas. This antenna is often built of printed circuit board material, and the substrate makes up a patch antenna's dielectric. The distance between the patch and the ground plane, the substrate of dielectric height, h, determines the bandwidth. A thicker substrate increases the gain to some extent, but may lead to undesired effects like surface wave excitation. Surface waves decreases efficiency with perturb the radiation pattern. Last one is the summary. The use of small antennas is a promising new concept in wireless communications. Microstrip patch antennas are lightweight, inexpensive, and designed for use on rigid surfaces, making them suitable for mobile stations, aircraft, and other applications. It has a microstrip antenna. The most basic type is a radiating patch on the one side of a dielectric substrate, with the other side's earth plane. Microstrip patch antennas are small, cheaper, and specially used in rigid surface, making them ideal for mobile station, aircraft, etc. Microstrip antenna in its simplest form consists of radiating patch on one side of the dielectric substrate and has a ground plane on the other side. The patch can be of any shape, but conventionally, shapes are generally used to simplify analysis and performance prediction. The antenna designed at resonant frequency of 3.04 GHz and a bandwidth of almost 69 MHz, as shown as is in S11. There are several methods to increase bandwidth of patch antenna. In our case, we increase the bandwidth with the help of substrate height between the ground plane and the radiating patch. Under dielectric substrate, which dielectric constant 1 and height of 4 mm between patch and ground plane is used. A simple coated feeding technique. A simple coaxial feeding technique is used to make antenna simple finally. A finite large enough ground plane is designed to support the patch. And this is the last part of my report, the multiple choices that I prepare on this report. And I have 5 questions. And that is all my report, sir. Thank you and God bless.